This is problem number 20, chapter 21, number 33. Okay, so we have to draw a picture of a circuit diagram. The particular circuit they give us looks like this. So we come up through a resistor, then we come through a battery, and then we go through another resistor, we come back down and we hit this junction and we cut over, or we could go down through another resistor, then we go through another resistor, and we have another battery, and we come back around and wrap up. Okay, they give us some values for these resistors. They tell us R2 is a big R2, and that's equal to 2.5 ohms. They give us a value for this battery. The EMF in the battery is 18 volts. They give us another resistance. This is little r1, and that's equal to 0.5 ohms. They give us this resistor down here. I missed the resistor in the middle path. That was R1. Yes. They're just resistors. I don't know why they called them both R1, one big and one little. That is a good question. So we have big R3. Big R3 is 1.5. We have little R2. Little R2 is 0.5. And then we've got our second battery, and that is 45 volts. Okay, so they give us values for all of those. Then they gave us some currents, and they have currents splitting around. So we have a current I2 that's going up. So that's running through this entire upper part of the circuit. Kind of runs up, runs around. I2 is still going through here. We've got a current I1 going through the middle. And everything I'm doing here, this is all given in the picture. This is all in the book. And then we have an I3 going through the bottom part of the circuit. Current I3. And it wraps back up there. And then they give us these letters. They give us a bunch of letters to be reference points. We have a letter A. We have a letter B. Letter C. Letter D. Got a letter E. Oh gosh, this is a huge picture. F. G, and H. Okay. And now we need to solve this. Okay. Lots of stuff here, lots of things we can do. We are asked to find what are the values for all the currents. So we want to know what's I1, I2, and I3. What are all of these values? Okay. Any questions on this so far? No? Everybody have the picture drawn, because I got to shrink it down. Yeah, questions? Is what? Yeah, that's a 45, believe it or not. My chicken scratch handwriting. How many of you use any of you use tablets? Write on tablets? It's tricky, because I don't have a fancy one, so I have to kind of hover my hand above everything, so I'm writing like this. It's an art form. Should have seen the first lecture videos I made. They were horrible. Okay, so we can shrink this down. We can kind of move this to the upper corner. And we're going to try to refer back to this picture. So can we see at least a little bit of that? The first thing we want to do is we want to identify junctions. So you can look at your pictures to find the junctions. If I look, the junctions are where the current splits. I have current splitting at the point A, and I have current splitting at point E. So I can pick either one of those junctions. If you remember last time, both junctions give the same thing, right? Do you remember what the junction rule was? Yeah, Charlotte. Current in equals current out. So for junction A, I can write the junction rule. What currents are going into junction A? Look at your pictures or look at the picture up here if you can see it. I1 is going into the junction. What current is going out of the junction? I2 plus I3. So the current in is equal to the current out. Now if I want to go through and do some math to actually solve this, I want to solve for I1 and I2 and I3. How many variables is that? 3 variables. So how many equations do I need? I need 3 equations. However many variables I need, that's the number of equations I need to be able to solve it. So to get more equations, I'm going to turn to the loop rule. So the loop rule is where you add up the voltages across the circuit in a closed loop. And what is the sum of the voltage going to give you? 0, when you add up all the voltages. So let's do one of the loops. Your book does A, E, F, G, H, A. So we're going to go A, E, F, G, H, A. Let's see if we can do that in a different color. So we're going to start at A, and then we're going to go over to E, and then we're going to go down to F, G, H, and back up to A. So that yellow line is our loop. Yeah? Going through the bottom part of that circuit. So what is that loop going to give us? I start at A, and I look. My loop is going, looks like it's going to the right through resistor 1 first. I'm going to the right through resistor 1. What direction is my current going? My current is going to the left. And how big is my current? Which current is going through resistor big R1? I1. So since the loop and current are going opposite directions, that's a positive I1 times capital R1. Is this making sense? So I start at A, and I'm going to the right through resistor R1 with the current I1. I'm going to the right through there in my loop. The current is going to the left, so I have a positive voltage change. And then I keep going and I reach point E. At point E, do I go up or down? At point E, I'm going to start going down. So my loop is going down through this resistor. Looks like this is R3. What direction is my current going through R3? My current's going up, and it's a current I2. Or no, current I3. So since they're going opposite directions, I'm going to be adding that. Yeah. So I would do plus I3 times R3. Let's keep going around our circuit. I reach the point F. I'm going to be going through resistor R2. I'm going to the right through resistor R2 with the current I3, which is going to the right. Looks like actually my loop is going to the left, right? And my current's going to the right. So that is going to be opposite directions. Yeah? So is that positive or negative? Positive. Plus I3 times R2. That's little R2. I keep going through my circuit. I reach this battery. I'm going from the positive side of the battery to the negative side. Is that positive or negative? That's negative. I'm going from a higher value to a lower value. The only way I can do that is with a negative drop. So I'm going to subtract off this second battery. And then I keep going around. I loop back around from my battery to point A. That gets me back to where I started. So that's my closed loop. So what is that equal to? That's going to be equal to 0. Yeah? Any questions on that? Yes. How this is negative? I can't. So this might not appear on the recording. So, and the battery, I'm going from the positive terminal to the negative terminal. So the positive side of the battery is a big value. The negative side is a smaller value. So I have to decrease the from higher to lower. So that's negative. So we're going to plug in all the numbers that we have. Yeah. Any other questions? Okay, so let's plug in the numbers that we would actually have. So I don't know any of the currents, so I can't plug in numbers for any of those, right? But I can plug in all the resistors, because I have all the resistors. So I have I1 times R1, and R1 is equal to 6. Plus I3 times R3. R3 is equal to 1.5. Plus I3 times little r2. Little r2 looks to me 0.5. Minus E2, and E2 was 45. That's equal to 0. And I can simplify this a little bit, can't I? I've got 1.5 I3 plus 0.5 I3. What would that become? That's 2 I3. So I just combine like terms. And I'm going to shuffle things around a little bit. I don't like it when the numbers come after my letters. I like the numbers to come before. So I'm just going to move them to be before. That's okay. So I have 6 times I1 plus 3 times I3 minus, sorry, that's not 3, 2. I3 minus 45 equals 0. Is that what everybody else is getting? Yeah? So I'm going to call that another equation. That's just another equation that we can use, right? How many equations do I need? I need 3 total. I have my current equation. Now I have another equation. Now I need another loop. What other loop did they use? They used the top loop. So the top loop looks something like A, B, C, D, E, back to A. So I'm going around this way. Yeah. So the top loop, I'm going to go up through the top loop. My loop is going up, which is the same direction as my current. So if I'm going the same direction as the current, what does that mean for any voltage change? Any voltage change has to be negative. So this is going to have to be a negative, whatever current is going through there. What is that current? That's I2 times resistor, that big R2. And then I keep going around, and I reach my battery. When I'm at my battery, I'm going from the negative side to the positive side. So is that going to be an increase or a decrease? The negative is low. I have to get high. To get high, I need to, well, you need to go to DC. No, you need to go from the negative to the positive, so I need to add. Yeah. So I need to add E1. I need to remember that I'm recording this. I'm getting in trouble. Then I keep going. There will be strange comments on YouTube videos, because I post this to YouTube, and they'll be very confused. We have this resistor. What resistor is this? That's little r1. It's going, the current going through it is I2, looks like. And the loop and current are both going the same direction. So that's got to be a negative. So I have to subtract off the negative I2 times the little r1. And then I keep going around. I reach my point E. My point E, I'm going to turn to the left, and I'm going to be going through this resistor. I'm going the same direction as the current is going, so that's going to be another negative. So that's going to be a negative I1 R1, where that's big R1. And then I reach back to my starting point, so that's going to be equal to 0. Yeah? Any questions? And then I can plug my numbers in, right? So I'm going to plug my numbers in, and I'm going to combine like terms. I'm going to do this all in one step. You can do the algebra out yourself if you really, really want to. But if you do out all the algebra, you'll get 3 times I2 plus 18 minus 6 times I1 equals 0. Let's do the algebra to actually solve for these things. So we have 3 times I2 plus 18 minus 6 times I1. That's equal to 0. And I said we want to solve this for I2. So I want to get I2 by itself. So I'm going to add I2 to the other side. Add the I2 over to here. So I get 18 minus 6 times I1 equals negative 3 times I2. I still want I2 by itself. Sorry, I add this over, so when I do that, that becomes positive. Yeah. I want to get I2 by itself. How do I do that? Divide both sides by 3. And I have to divide every part of both sides by 3. So 18 divided by 3, what does that give me? That gives me 6. 6I1 divided by 3 gives me 2 times I1. And that's going to be equal to I2. So we'll circle that equation. Let's now solve the other one that we have. We have 6 times I1 plus 2 times I3 minus 45 equals 0. So I'm going to move the other pieces to the other side. So I have 2I3 equals 45 minus 6I1. Just do an algebra. Divide both sides by 2. Get I3 by itself. I3 equals 45 divided by 2. What's that? 22.5. 6I2 divided by 2. What's that? 3I2. Sorry, not 3I2, 3I1. Yeah. So now I have these two equations, and they're both in terms of I1. I know that I1 equals I2 plus I3. So I can take this I2 and add it to this I3 and have another equation. Yeah? So let's do that. I2 plus I3. So these kinds of problems aren't necessarily that hard. They're just, it's a lot of bookkeeping. That's what makes them tricky, I think. Plus I3 is 22.5. There's a lot of steps, but you can always follow the exact same steps and you'll always get the right answer. So I plugged in for I2, and I plugged in my equation for I3, and adding them together, because I1 is I2 plus I3. So then I have I1 equals 6 plus 22.5, so it's combined like terms. 6 plus the 22.5 is what, 28.5? And negative 2i1 minus 3i1 is minus 5i1. And I can move the i1 to the other side. So I get 6i1 equals 28.5. Yeah. And then I take all of that, divide both sides by 6, and I1 is equal to 28.5 divided by 6. What do you get when you do that? Put it in your calculator. 4.75. So that's current I1. Yeah. So now to finally solve the problem, you get your I1, plug it into your I2 equation, and you get your I3 by plugging in I1 to the I3 equation. Let's do those. So I2 equals 6 minus 2 I1. I1 plugs in. I2 is 6 minus 2 times 4.75. I2 then gives us, what do you get when you multiply that all out? Looks confusing to me. I'm not so sure I'm right. What do you get? 6 minus 2 times 4.75. Do it. Calculators. Negative 3.5. Can I have a negative current? Am I allowed to do that? Can you have negative currents? There's a vote for no. There's multiple votes for no. YouTube, like, comment, subscribe, share. Tell me, can you have negative currents? I circled this. I usually don't circle things until it's the right answer. So that's the right answer. I can have a negative current. So this is an entirely valid answer. What this tells you is, at the very beginning of the problem, we chose the direction for the current to be. We said that current 2, I believe we said it was going kind of up and kind of clockwise through the upper loop. If you get a negative current, that just means you chose the wrong direction. The current is actually flowing counterclockwise. Yeah, so in my circuit picture, I had this box and this box, and I said that current, I think current 2 was going up around like this. I got a negative value, so that means that the current is actually going the opposite direction. There's nothing wrong with that. That's perfectly fine. Okay. So let's do the same thing for I3. Let's figure out what I3 is. I3 equals 22.5 minus 3 times 4.75. What do we got here? What do you got? Tell me. 8.25? Is that the right answer? What do we think? Is that right? Can we check this? Yes, how can we check it? I need to make sure that I1 plus I2 plus I3 has to equal I1. Yep. So I2 plus I3. Let's see what that's equal to. Negative 3.5 plus 8.25. What does that equal to? It's what? 4.75. Okay. What's it supposed to be? That's what I1 is. That's what it's supposed to be. So I3 is right. We can circle it. So that's an entire Kirchhoff's law problem. Any questions? Any questions that you want recorded? No?